Microsoft published a detailed research paper about its compact AI model called Orca. Written by 6 of the company's best computer scientists, this robust research paper provides all of the inside details of what the new software will offer. In this video, we'll explain all the features and benefits of the Microsoft Orca AI model in the simplest way possible, such that even a grade 5 student will be able to understand how it works and why it is the next big thing in the AI industry. So, without wasting any more of your time, let's get right into the video. First things first, let's check out the research paper right here. From the title, you can tell it has some sort of connection with GPT-4, which is the language model that powers other prominent AI models like ChatGPT and Bard. As this video progresses, I will explain the strange connection and also tell you why Orca is different. However, for now, let's concentrate on the other important details mentioned in the paper. In the very first paragraph, the scientists talk about how recent research has focused on enhancing the capability of smaller models through imitation learning, drawing on the outputs generated by large foundation models, LFMs. Basically, what they're saying in essence is that there's an emerging trend in the AI industry where scientists are using the imitation learning technique and the output of large foundation models to improve the performance and efficiency of smaller language models. Over time, this method has proven to yield good results, but where scientists seem to be getting it wrong is that they deploy the same style used in large language models to design these smaller models, but unfortunately, they don't incorporate the reasoning process of large language models when designing small language models. Expectedly, this creates a significant gap in the cognitive ability of both language models, which scientists tend to overlook. This sometimes makes them overestimate the performance of small language models, and eventually, when it's time to deliver on the endless promises, they falter. And that's exactly what Microsoft is looking to change with the Orca AI model. The potential of this incredible tool is limitless because it's going to change how both large language models and small language models are trained. Orca is a compact AI model that imitates the thought process of large foundation models like GPT-4. Through a judicious sampling and selection technique, Orca is able to access the large-scale data and rich signals embedded in large foundation models. Some of these signals include explanation processes, complex instructions, and even step-by-step thought processes. So, in other words, Orca can be defined as a mini version of a large AI model. It's trained with fewer data, but critically, it's expected to deliver the same quality of performance and results as large language models. This is quite some expectation, because as I mentioned earlier, Orca is trained with less data, but surprisingly, when compared with other language models, it seems to be holding up well. In case you haven't heard about it, Vicuna is an intuitive open-source AI chatbot trained by fine-tuning Llama on user-shared conversations collected from ChatGPT. The model was trained with just 13 billion data parameters. I'll explain what parameters are in a bit. However, the preliminary evaluations by GPT-4 showed that the Vicuna 13B AI model delivers 92% response quality, beating the likes of Llama and Alpaca. As you can see from the chart here, only Google Bard and ChatGPT have a better response quality than Vicuna, and that's okay, because the difference is not so much, and as you know, Bard and ChatGPT were trained with more data parameters. Large language models in AI are generally compared by the number of parameters, where bigger is usually better. The number of parameters is a measure of the size and complexity of the model. The more parameters a model has, the more data it can process, learn from, and generate. However, having more parameters also means having more computational and memory resources. Parameters are learned or updated during the training process by using an optimization algorithm that tries to minimize the error or the loss between the predicted and the actual outputs. Just to show you how sophisticated the Vicuna model is, let's check out this example right here. As you can see, Vicuna is compared with Alpaca, which is also trained with 13 billion parameters. Both AI models were asked to compose an engaging blog post about a recent trip to Hawaii, highlighting cultural experiences and must-see attractions. Judging by the quality of the answer, you can tell that Vicuna is the superior model, and I have a feeling that if you ask ChatGPT or Bard the same question, the quality of answer wouldn't be too different in comparison to Vicuna. This brings us to our next point of discussion, which is zero-shot learning. Naturally, as humans, we tend to utilize our previous knowledge to solve new problems. For instance, a person can utilize their knowledge of jumping to scale a fence in an emergency situation. Similarly, a student can use their basic knowledge of math to solve more complex problems in other subjects, like physics and further math. And this is the exact concept behind zero-shot learning. Basically, zero-shot learning, known as ZSL for short, is a form of transfer learning designed to learn patterns from labeled data in order to detect classes that were not seen during training. This is quite impressive because it means any AI model with this functionality will be able to predict and respond to unseen classes. Nowadays, in computer vision, the ZSL technology is often deployed for image classification, where written information from a novel class is used to find the relationship between the description of the class and its visual representation. Like in this example here, the seen classes on the left are horse, tiger, and polar bear. These are basically the data parameters that the language model has been trained with. Normally, in this case, the model shouldn't be able to recognize zebras because it is not part of the parameters it was trained with. But using the ZSL technology, it can combine the shape of the horse with the stripes of the tiger and the black and white color of the bear to create a zebra. In all the demonstrations we've seen, Orca ranks almost at par with ChatGPT, but more significantly, it performs exceptionally well in professional examinations like SAT and LSAT. For this particular demonstration, the researchers used GPT-4 to evaluate the performance of ChatGPT and Bard with a series of small language models, including Orca. And surprisingly, Orca outperforms all of the small language models and even the so-called large language models with an outstanding 103%. ChatGPT comes second with 100%, and Bard comes third with 93%, and Vicuna scores an impressive 92%. Similarly, these AI models were compared based on their ability to answer professional and academic exams. Here, ChatGPT came out on top with 47%, while Orca came second with 42%. If you notice, the difference between ChatGPT and Orca isn't that wide. This is exceptionally impressive because, as we know, Orca was trained with only 13 billion parameters, while ChatGPT has 170 trillion parameters. If we compare the numbers, you'll find that ChatGPT contains 13 times more parameters than Orca, but somehow, Orca manages to deliver about the same level of performance. So, as you can see now, this is why there is so much hype around Orca. This means that Orca is lightweight and can be integrated into smaller devices. This reminds me of the new Palm 2 AI model unveiled at Google's I/O Developers Conference. Unlike other large foundation models, Google announced that the upgraded version of Palm 2 will be available in 4 different sizes, including Gecko, Otter, Bison, and Unicorn. As the smallest amongst all of these sizes, the Gecko version of Palm 2 is the most flexible.
Gecko is so lightweight that it can work on mobile devices, fast enough for great interactive applications on device, even when offline.
Of course, the features of Palm 2 and its different versions are much more than this. So, if you're looking to learn more about it, we've made an entire video explaining how it works. At the end of this video, you'll find a pop-up screen leading to this tutorial, but alternatively, we'll put the link in the description for you. Alright, back to the Microsoft Orca AI model. One of the most interesting things about this tool is that aside from its flexibility and compactness, there's also a possibility that we end users might be able to use it offline because it's a smaller sized model with fewer parameters than its competition. This would be a real game changer, especially because of the current AI models like ChatGPT and Bard don't offer this feature yet. Imagine having access to an advanced language model like ChatGPT and Google Bard without the internet. That would be something extraordinary. For starters, it would definitely come in handy when users find themselves in areas without internet connection and other emergency situations. Interestingly, some users are already trying out the offline modes of AI models, like Llama. OpenAI, the company behind ChatGPT, has just launched a groundbreaking humanoid robot project in collaboration with a Norwegian startup known as 1X Technologies. Equipped with several advanced security and monitoring systems like cameras, motion detectors, and alarm sensors, This intuitive robot is already being tested as a security guard in an Android manufacturing site, and there are already suggestions that it could be powered by an advanced offline AI model sometime in the future. Going back to the research paper released by Microsoft, scientists compared Vicuna, ChatGPT, based on their aggregate accuracy for complex zero-shot MCQ reasoning tasks in Big Bench Hard. Again, Orca performs impressively with an aggregate accuracy of 49.7% as against ChatGPT, which has an accuracy of 48.9%. In simple terms, Big Bench, otherwise known as Beyond the Imitation Game benchmark, is a widely accepted standard for testing the cognitive ability of large language models and predicting their future capabilities, while MCQ is known as multiple choice questions. So, basically, the zero-shot reasoning task in Big Bench Hard was set up to test the ability of Vicuna, ChatGPT, and Orca to select the correct answer for a question from a multiple choice set of answers. Now, this test is not easy at all. It's like a big puzzle that only a really smart AI model can solve, so it's really impressive that Microsoft Orca did well in it, even scoring a higher percentage than the famous ChatGPT. Oftentimes, with AI models like this, users always find it difficult to come up with the right prompts to get the required answer. But what these researchers have done is they've curated a set of 16 handcrafted system messages to evoke different kinds of responses from large foundation models, which ultimately gives Orca a wide range of functionality. The fourth message is actually one of the most popular and effective prompts you'd ever find for an AI model. Here we tell the GPT-4 language model, "You are a helpful assistant who always provides explanation. Think like you are answering to a 5-year-old." This basically tells the AI model to return simplified answers that a 5-year-old child can comprehend. If you go further down to the 7th message right here, you'll find a similar prompt. "You're an AI assistant. User will give you a task. Your goal is to complete the task as faithfully as you can. While performing the task, think step by step and justify your steps." Unlike the first prompt, which specifies what the tone of the response should be, this particular prompt stipulates the step-by-step thinking process that must be used to solve the process. According to experts, this method actually improves the quality of results generated and is superior to zero short language models when it comes to solving diverse reasoning tasks, like arithmetic and other logical reasoning tasks. But critically, the step-by-step reasoning technique doesn't necessarily guarantee that an AI model will deliver the desired result or response. In fact, in a recent TED Talk, Yejin Choi, an expert in natural language processing and a 2022 MacArthur Fellow, demonstrated how even the most sophisticated AI models can fumble basic common sense questions. For instance, here we asked ChatGPT a relatively simple question. "I left 5 clothes to dry out in the sun. It took them 5 hours to dry completely. How long would it take to dry 30 clothes?" Shockingly, the GPT-4 AI model, which is trained on 170 trillion parameters, says it would take 30 hours to dry 30 clothes, which is clearly wrong. Just in case that's a one-time let-off, let's try another easy question. "I have a 12-liter jug and a 6-liter jug. I want to measure 6 liters. How do I do it?" Everyone knows that the right thing to do is to measure with the 6-liter jug, but GPT-4 strays completely off point. First it talks about filling the 6-liter jug completely, then it talks about pouring the water from the 6-liter jug into the 12-liter jug, but from then on it just continues to say gibberish things. For the avoidance of doubts, let's try this question here. Would I get a flat tire by bicycling over a bridge that is suspended over nails, screws, and broken glasses? Any sensible person should know that since the bridge is suspended over these dangerous elements, they shouldn't have any effect on the bicycle's tires. But GPT-4 cannot seem to comprehend the question. In fact, it performs woefully, saying, "It is very likely that you would get a flat tire if you bicycle over a bridge that is suspended over nails." And we know that's not true. It's shocking to see how GPT-4 fails to answer these questions. But then again, we must remember that despite being trained on 170 trillion data parameters, its cognitive ability cannot be compared to that of humans. For example, as humans, we have the ability to make hypotheses and experiments in a bid to learn how things work around us. Over time, this ability improves significantly, allowing us to solve complex problems. But unfortunately, AI models don't have that at the moment, and that's why you see them failing simple questions that a brilliant 15-year-old student will knock off easily. With that said, The AI industry is evolving really fast, and it'd be interesting to see how Orca and other new language models will be able to learn human common sense and tackle these logical questions. Do you think this will happen in our lifetime? Let us know your thoughts in the comments section, and don't forget to like, share, and subscribe to our channel for more content like this. And if you like this video, check this one out as well.